Hello students, I am Aishwarya Mohan. I completed my MTech in Power System and Control. I will be teaching you the subject Electrical and Electronic Measurements for the GATE examination. So here we are going to do the GATE previous year question solutions. So for this we have 7 chapters. The chapter 1 is the characteristics of instruments. Second chapter deals with voltmeters and ammeters. Chapter 3 is about the resistance measurement. Chapter 4 AC bridges. Chapter 5 energy and power. Chapter 6 is about CRO and the measurements. And final chapter is the instrument transformers. So moving to the first chapter, characteristics of instrument. First question, a precise measurement guarantees accuracy of the measured quantity, true or false? So preciseness means closeness of readings, and so it does not guarantee the accuracy, so it's the false. Second question is 4 ammeters M1, M2, M3 and M4 with the following specifications are available, and we have a tabular column showing the characteristics, that the full scale value and the accuracy as the percentage value. Okay, we have a dual slope PMMC electrodynamic moving iron meters and its full scale values, and the accuracy is given. A current of 1 ampere is to be measured. To obtain minimum error in the reading, one should select the meter. Which meter should be selected for the minimum error? Okay, so we know error equal to full scale deflection into accuracy, and so we have given the full scale deflection of each of this meter and the accuracy. Accuracy is obtained in the percentage value, so we have to convert. Substituting all these values in the equation, we will get the error of the meters. This error is equal to full scale deflection into accuracy. Full scale deflection is given in this table, and the accuracy is given as a percentage of the full scale. So error will be equal to full scale deflection multiplied by the accuracy value. So 20 for the first meter, it will be equal to 20 into plus or minus 0.1 by 100. So it will become plus or minus 0.02. So for the second meter, this is for M1, M2 and this is for M3, and substituting all these values and the corresponding meters, we will get the least error is obtained for the fourth meter. That is, fourth meter will have the least error. So it will be option D. Now the third question, a current of 2 plus root 2 sine 314 t plus 30 degree plus 2 root 2 cos 952 t plus 45 degree ampere is measured with the thermocouple type 5 ampere full scale class 1 meter, and the meter reading would lie in the range. So we have to find that the thermocouple, the thermocouple type instrument. So we have 4 options. We have to find the range of the meter reading. And thermocouple type instruments will always read the RMS values, and so from this signal, current signal, we have to find the RMS value. IRMS will be equal to root of all these values. Okay, so 2 square plus root 2 by root 2, we have to convert this peak value into RMS values. So root 2 by root 2 the whole square plus 2 root 2 by root 2 the whole square. So the answer will be 3 ampere. For a class 1 meter, the accuracy is 1% for a 5 ampere range, and for 3 ampere the accuracy will be equal to 5 by 3%, which will be equal to 1.6%. So it is option C. Okay. Fourth question, resistance R1 and R2 have respectively nominal values of 10 ohm and 5 ohm and tolerance of plus or minus 5% and plus or minus 10%. The range of values for the parallel combination of R1 and R2 is. We have to find the range of the values of the parallel combination of R1 and R2. So the nominal values are 10 and 5 ohm, the tolerance 5% and 10%. So the range of R1 will be equal to 10 plus or minus 10 into 5 by 100. Okay, and that is the tolerance 10 multiplied to the tolerance of 5% and 10%. So for R1 it becomes 10 plus or minus 10 into 5 by 100, which will be equal to 9.5 to 10.5. 10 plus or minus this value will be equal to 9.5 to 10.5, and for R2 it becomes 5 plus or minus 5 into 10 by 100, should be equal to 4.5 to 5.5, and the parallel combination of this will be equal to, when two resistors are connected in parallel, it becomes like this, R1 R2 by R1 plus R2. So according to this equation, the range of this parallel combination is from 9.5. Here we have 9.5 at the high, and the low value is 9.5 and 4.5, and then 10.5 to 5.5. So the range will becomes, with the parallel combination, substituting all these corresponding high and low values here, we will get the answer as 3.05 to 3.61 ohms. So the answer is option 3.05 to 3.61. So the answer is option A. Moving to the next question. A variable W is related to three other variables x, y and z. Thus, W equal to x, y by z. The variables are measured with meters of accuracy plus or minus 0.5% reading plus or minus of full scale value and plus or minus 1.5% reading. The actual readings of the three meters are 80, 20 and 50, with 100 being the full scale value of all the three. The maximum limiting error in the measurement of W will be. So we have given the full scale value as 100, and the actual readings of all the three meters are 80, 20 and 50, and the accuracy of the first meter x equal to plus or minus 5% of this 80, and the plus or minus of full scale. For the second meter, we have to check. For the second meter, the accuracy is plus or minus 1% of the full scale value, not for the reading. So it's 1.5 into 100. Okay, and again 1% into 100 by 100, and for this it's about the reading 1.5 into this 50 value. Not here for y it's not 20, and it's the accuracy is plus or minus 1% of the full scale value. It's not 20, it's 100. And the maximum limiting error in the measurement of the W will be. So we have to find the maximum limiting error. We have given the readings of x, y and z as 80, 20 and 50. We know how to find the limiting error. It's plus or minus accuracy into full scale deflection. It is plus or minus 0.5% of the reading. Okay, limiting error is plus or minus 0.5% of the reading, which becomes plus or minus 0.5 into 80 is the reading of the meter x. So 80 by 100, it becomes plus or minus 0.4. And for the instrument y, it is plus or minus 1% of the full scale reading. So 1 into 100 by 100, it's plus or minus 1. And for third one, it's 0.75. So we have given the relation W equal to xy by z, and here we have to find the limiting error of the variable W. Applying log on both sides, we will get log W equal to log x plus log y minus log z. So differentiating with respect to W, we will get log delta W by W equal to dou x by dou y, dou x by x plus dy by y minus dz by z. So for the maximum limiting error, we will get all these values. We know what's the value here. Delta x equal to 0.4, dy equal to 1, here z is equal to 0.75, and for x by z we have 80, 20 and 100. So substituting all these values, we will get the error as plus or minus 7%. So the answer is option D. Moving to the next question. When the resistance bridge shown in the figure is used to find the value of resistor Rx, we have the Rx. The galvanometer G indicates zero current when R1 equal to 50 ohm, R2 equal to 65, R2 equal to 65 and R3 equal to 100. If R3 is known with plus or minus 5% tolerance on its nominal value of 100 ohm, what is the range of Rx in ohms? So we have to find the range of Rx, and if R3 is drawn with plus or minus 5%. So R1 equal to 50 ohm, R2 equal to 65 and R3 equal to 100 plus or minus 5%. We know for a Wheatstone's bridge under balanced condition, it will obtain a ratio of R1 by R3 equal to R2 by Rx. We have to find Rx. So Rx will be equal to R2 R3 by R1. We have to find the range. So 100 plus or minus 5% will be equal to 105 and 95. So substituting the corresponding value for R3, we will get R2 equal to 65 and R3 equal to 105 in the first case, divided by R1, that is 50, we will get 136.5, and for 95, that is 100 minus 5%, 65 into 95 by 50, that is 123.5. It will be equal to 123.5. So this is our range. So the option will be equal to option A, 123.5 to 136.5. So that's all about the previous year questions related to the chapter characteristics of instruments.